In this video, we're going to explore 3 patterns of how you can integrate your Azure DevOps pipeline with OpenShift. But let's first look at the why of Azure DevOps and OpenShift. And these decisions usually span a lot of groups, but if we just take the IT stakeholders, i.e. developers, architects, and operations, there are multiple reasons. For developers who may already be familiar with Azure, taking on another set of tool chains may not be desired, and having OpenShift as a new deployment target means the impact to change will be a lot less. It is also a single place to manage all your CI/CD, whatever the target. For IT architects, OpenShift is an enterprise Kubernetes distribution that provides an unrivaled level of security, and you may have many clusters across your entire organization. For instance, ensuring consistency and portability is key. And for operations, the consistency and automated aspects of Azure DevOps and OpenShift really means they can sleep at night. So before we dive into the patterns, I want to introduce the components that are really used underlying in the patterns. And I've really found these patterns to really get a frictionless experience of connecting Azure DevOps and OpenShift. So first of all, it's the OC CLI tool. Now this little tool basically allows you to log in and use all of the OpenShift APIs through a single command line. You can do things like simply launch a container, create and run a build job, remote shell, or even use port forwarding from containers. The OC CLI tool is supported on Linux, Mac, or Windows, and various other platforms. Now, having OpenShift as our target to deploy today, I will talk about some of the resources which the CI/CD build pipeline interacts with. OpenShift is an enterprise Kubernetes distribution, so includes Kubernetes resources like deployment, service, pods, where the actual workload runs, and these are noted in the blue in the diagram. But OpenShift brings resources and functions to help automate and make Kubernetes an easier experience for developers. So in our CI/CD pipelines patterns, we would make use of the source to image capability, which takes source code and spits out a containerized build, and as well as the Kubernetes deployment resources. And this means I don't need a Docker or Kubernetes YAML file and can simply apply some OC CLI commands and configuration to build and deploy my code. So let's look at the 3 patterns for Azure DevOps and OpenShift. The first pattern is the use of the OpenShift extension. This extension allows you from within Azure DevOps to use that OC CLI tool. Now this extension is freely available in the Azure Marketplace and can simply be installed in your organization in Azure DevOps and then will appear in the taskbar ready to be used by the pipeline. The high-level overview of how you would set this up is we have a project in GitHub, we have a pipeline definition within Azure Pipelines that will run within an Azure hosted agent, which is typically an Ubuntu VM, and the OpenShift extension will seem as a task there and will talk to the OpenShift cluster. And ultimately, you can use those OC commands and execute source to image builds. You can also look to deploy and roll forward various different arrangements as you want to sort of set up your pipeline. And if you refer to the videos following this video, you will start to see this in action. Now that's all well and good, but as a Java developer, say, I have another option. So for this pipeline here, I could use the JCube OpenShift Maven plugin. Now this does make use of the OpenShift extension. It's still part of the first pattern, but as a simple sort of 4 steps, I log into OpenShift with the OC CLI tool. I then do a Maven clean OC resource, which builds by OpenShift resource descriptors. I start a source to image build via a Maven package OC build, and then deploy my application to the OpenShift cluster. So I'm including that in pattern 1 because it makes use of the OpenShift extension, but you could simply use Maven type commands to drive the underlying OC commands. So the pattern 2, rather than the OC extension, you could just use the generic Kubernetes extensions present within Azure DevOps. OpenShift supports the kubectl tool as much as the OC tool. And in much as the same way we have seen the OC extension work, the Kubernetes extension works in a similar way. The pattern here would be to use the Azure hosted agent, and we would basically use the Kubernetes extension to interact with OpenShift. Within the extension, I would need to set up the install or the service connection as well, and I also need to set up a Kubernetes environment. So there's a couple more steps within Azure pipelines that you would need to set up. And then I can basically do this, I can set up OpenShift to deploy in a generic Kubernetes fashion, where I would create all the YAML ahead of time. I'll do my Docker build and then deploy it into OpenShift. Now the third pattern I found, and probably the one I'm most excited about, is using the Azure DevOps model of the self-hosted agent. In the previous two patterns, this would require the OpenShift API to be exposed to the SaaS Azure DevOps in the cloud. However, in this model, the OpenShift API does not have to be exposed, and this is perhaps the best option for private clusters. At a high-level view, I'm still working within the Azure pipelines, but rather than an Azure hosted agent, I'm directing my pipeline to be run within the self-hosted agent. In this case, I built a self-hosted agent running as a pod within OpenShift. This pod is running in a service account with sufficient permissions for what it needs to do, like store container images in the registry, run build jobs. Within this generic agent, I've actually put in the OC tool, but you can customize that agent for what your needs would be. But simply having the OC tool within there, I can start to execute all those source to image builds which cover Python, Node, .NET or Java. So it's a sort of a generic build agent that you will see in the following video in the demo, and so therefore I can run almost any workload. Now OpenShift can also support Windows nodes, so you could build a self-hosted agent for Windows as well. So let's look at the summary, the three patterns. We've got the Azure Pipelines OpenShift Extension, we've got the Azure Pipeline Kubernetes, or I'm including Helm within those pattern 2, and we've also got the self-hosted agent. Now which pattern is best? This very much depends. Is your cluster API open to the Azure DevOps environment? Self-hosted agents may consider to be better security. Do you need to build with Red Hat based images? Using S2I and making use of the OC tool makes sense. Do you plan to also develop your Kubernetes YAML? Then pattern 2 may offer exactly what you need. But for me, after working in this model for a while, I've really appreciated the tooling in Azure and thought a multi-stage job combination of doing build and unit tests in Azure and following successful tests, taking advantage of the secure-based images OpenShift provides, and let OpenShift do the containerization part via a self-hosted agent. That's it for my 3 patterns today. In the subsequent videos, you'll see demonstrations of each of these patterns. Thank you very much.